Hi everyone. I know we had kind of a struggle in class last time doing problem 5 on the notes. It was kind of confusing and crazy, and so I figured I would try to help us with that and make a video of a similar problem that we can use to kind of help us going forward in the future. So the problem I'm going to do for us today is going to look a little bit like this. The numerator is going to be 7x minus 8, and the denominator is going to be x squared minus 16. Okay. And if I was going to classify this kind of problem, the thing that makes this problem a little bit different is having two vertical asymptotes. Okay. Two vertical asymptotes, or the graph is going to be in more than two sections, will throw a little curveball on us. And if you're thinking, well, how do I know already that there are two vertical asymptotes? When I factor the denominator, I don't have anything with a hole. That's usually what we're going to see. The problems that we do with two vertical asymptotes most likely are not going to have a hole. Okay. And so we won't get that matching factor to cancel from the numerator or the denominator. So hole, none. Vertical asymptotes, x equals 4, x equals -4. With the domain, -infinity to -4, union -4 to 4, union 4 to infinity. Okay. Hopefully you're comfortable with those three things. The factoring of the denominator, that's that perfect square factoring that we talked about a little bit in class on, I guess that would have been Friday. And then the fact that we don't have a matching factor with the numerator and the denominator, so that is why we do not have a hole. And so the zeros of the denominator are strictly vertical asymptotes. I'm going to go on a little dual page here so we can look at this stuff and kind of graph at the same time. So if I'm over here graphing a little bit, that means vertical asymptote, vertical asymptote. So we're going to move that one over a little bit so it's more on the 4. So one of the vertical asymptotes at 4, one of the vertical asymptotes at -4. And so the graph is going to consist of 3 sections. Either one piece up here or one piece down here, one piece over on either side, but then the middle part is the part that's a little different. Okay. So let's continue to get some actual points and other information on this graph. Horizontal asymptote, because this is a bottom heavy problem, the horizontal asymptote is going to be y equals 0 or the x-axis. Okay. My x-intercept, 7x minus 8 equals 0, so 7x equals 8, so x equals 8 over 7, so 8 over 7, 0. So a little bit more than 1, a little past the 1. Okay. Y-intercept, oops, my eye, x of 0 means I'll be left with a -8 and a -16, which is 0, comma, +1/2. So if I put 1 there, positive 1/2. So I have those 2 points, and that's it. And that is sometimes where we get to be a little stuck, because oftentimes on the 2 vertical asymptote graph, we've got to do more extra points. And more extra points can be tricky because of the arithmetic we have to do. Okay. No, it wasn't 8. It was, let's rewrite the function. So 7x minus 8 over x plus 4, x minus 4. This is negative 4, and this is 4. I'm going to pick a couple points for x. I'm going to use a negative 5 and a positive 5 on either side, on the outsides of the asymptotes. And then I'm going to use a negative 3 and a positive 3, kind of on the insides of the asymptotes. These are going to be messy, for sure. The y's that we get for these are not going to be easy to calculate. But what we really just need to pay attention to with these is if they're positive or negative, and if we can approximate a number for each one, that will help us. Okay. So let's do the positives first because they're a little easier. So when I put a positive 5 in, it's going to be 35 minus 8, and then this is going to be 9, and this is going to be 1. 5 plus 4 makes the 9, 5 minus 4 makes the 1, 7 times 5 makes the 35, and so I'm looking at something that kind of works out really nicely. 27 over 9. Yeah, no surprise. I picked this so it would be a little more pretty than the one we tried to do. So add a 5. If I finish kind of marking off the graphs here. So 5, 3 is a point. And I'm going to use that 1 point and a lot of like just sort of knowing what rational functions do and say, okay, if I've got that 1 point, I'm going to get this kind of concavity picture right there. Okay, coming off of the point, going towards the asymptote, towards the vertical asymptote, towards the horizontal asymptote. I know it's going to head towards the horizontal asymptote on the right side and then towards the vertical asymptote on the left of the point. And now I'm going to see if my 3 might be equally lucky. 21 minus 8 when I put a 3 in over 7 and negative 1. Yeah, not going to get quite as lucky here. I'm going to get a 13 over a negative 7. And so what I'm going to use is, if this had been a 14 over negative 7 would be negative 2. So this is going to be about a negative 2. And that's actually close enough for me because I kind of knew I was probably going to do that. And I was going to connect to these guys. Now the question is whether I'm going to keep going up or I'm going to flop over. Oh, I know I'm not going to flop over. And here's how I know. If I had, this was the only x-intercept I had. And I've got this point and that point, and that's the only x-intercept I have. So when I connect through like this, I'm not gonna come back down. I'm just gonna kind of go like that, and I'm probably gonna do a little concavity change. And so that means, and let's hear how we can check that. Let's do the -3 work. 7 times -3. I'm going to plug the -3 in. Woo, I'm just erasing stuff now. Okay, let's try again. Let's plug the -3 in to this guy. So -21 minus 8 over a -3 plus 4 is 1. A -3 minus 4 is -7. Once again, not a very pretty number, -29 over -7. But that's definitely going to be something positive. So I know at -3, I'm at some positive number. I don't know exactly where. Well, I do know it's 29 over 7, so like almost around 4. Because 28 over 7 will be 4, but it's definitely positive. And so I'm going to guess, I'm going to probably do this over here. But let's check. Let's do the -5. -35 minus 8, -1, -9. So this is a -43 over a +9, which is a big old negative number. So the guide point for this curve is definitely down here somewhere. And so we get that piece. I know that this is probably the harder part of the graphing because it requires a lot of arithmetic that we don't have a calculator to support. That's what makes this problem the toughest, because we have to do so much extra work to get the points. Okay, I'm hoping that helps you a little bit. That's a little bit more clear than the cuckoo crazy problem I was trying to talk to you about in class. And I sort of remember that I changed one on the homework. I'm going to go ahead and look at that, and then I will clarify that on another message to you. Okay, hope that helps. Thanks, guys.